scatterplots, trendlines, and linear regression. We'll throw that in at the end. A correlation describes a relationship. Relationship. That doesn't fit in there. Relationship between two data sets. A graph may show correlation between data. Correlation can help you analyze data and make predictions. That looks awful. But to analyze data and make predictions, there are three types of correlations. Really, there are two, but our last one is going to be kind of this weird one. So the first is positive correlation. Positive correlation, which means as you go from left to right, your data is increasing. Second is negative correlation. Negative correlation means that as one set of values increase, you go from left to right, our data is actually going down. It's decreasing. So it kind of ties in with yesterday. Increasing, decreasing stays the same. And then the last one is no correlation, which isn't really a correlation, but it means that there's no relationship. So as you go from left to right, who knows what happens with the y values? They're just not going anywhere specific. So describe the correlation by each, and then sketch the trend line. All right, so first off, I would say this is a negative correlation. As you go left to right, it's tending to go down. Now what you can do is you can draw the trend line, which is a line that's going to go between, put arrows on that, a line that's going to go between all of those, and hopefully it is as close, it's close to all of them, so something like that would work. Now that has a negative, what we're going to call slope. It tends to go down, so it is a negative correlation. And as the value of x increases, going from left to right, what happens to the value of y? Because it's a negative, it's going to decrease. Number two, we have points that if I draw my line, it's going to look something like that. And so that tends to have a positive trend, so it is going to be a positive correlation. And so that means that as the value of x increases, the value of y increases. And then last, as you can guess, it's probably going to be no correlation. But if you draw a trend line, there really isn't a line that's going to be close to a lot of the points. So I don't really know what to draw for a line there. So this one is no correlation. And as x increases, I don't know what happens to y. Number 4, use the provided graph. So first, the type of correlation. First, if you look at it, it's tending to go up. As you go from left to right, the values are going up. They're increasing. So this is a positive correlation. Positive correlation. The independent variable, I always do this. I always draw an I on the x-axis and a D on the y-axis, because the independent variable is always on this x-axis. The dependent variable is always there. If you notice, the D runs flush. It just kind of hits right there. And the I sits real nice on the x-axis. So that tells me that my independent variable is rolls sold. The value down there. The dependent value is over here, the money raised. Now this is the first time we write a function statement. But these are always in the form of D, the dependent, is a function of whatever the independent variable is. So in our case, it's going to be money raised. Money raised is a function of rolls sold. The function of the number of rolls sold. Now for a little bit of prediction. So we are asked here, can you see that? Yeah, you might be able to see that. Actually, nope, won't be able to see that either. Alright, so we are asked here about how many rolls are sold when $800 has been raised. So if we look at 800, where 800 is money raised, we'd be somewhere around here. So tracing back down, that'd be something like 125 rolls. About, and I should probably write that, about 125 rolls. Next question, how much money is raised when 200 rolls are sold? So I'm going to start at rolls sold down here and trace my way up until it looks like I would be on my trend line, which is going to be somewhere around here. And so that looks like they're going to have raised more than 1,200, so let's go with approximately $1,300. And as usual, you need to ask if you have questions about this. Alright, there's number 4. So pause the video as you need and ask questions. Number 5, we get the same setup. Type of correlation, looks like it's tending to decrease, so it is going to be a negative correlation. The independent variable is always on our x-axis, so row number, because this is actually a concert for concert tickets. And the dependent variable is the ticket cost. Okay, now other than the graph, there is a way to tell this. It's which one of these depends on the other. And in our case, the ticket cost depends on the row number. Ticket cost depends on the row number. If you notice, this is in the same form as ticket cost is a function of. It's the dependent depends on the independent. It's always going to be kind of in that form. Kind of like with the function statements, which you're going to have a few of those, so make sure you go back and look at that. Alright, now next we have if you spend $45 on a concert ticket, which row are you sitting on? So if we start at 45 up here, in that color 45, and we trace over, looks like we're going to be about on row 15. And then if you buy a ticket on the 30th row, how much will that ticket cost you? Oh, let's see, let's go up here. There we go. It's up here at $20. Number 6, circle the scatter plot that best describes the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the oven after turning it off. Alright, so we're looking at this. So when the oven is turned off, it's going to be pretty darn hot, right? It's going to be pretty hot. So, and it's cooling off because of the time since we turned it off. So starting up and decreasing. So it definitely is not C. And this would say that when it turned off at 0, it was like 90 degrees. That's like room temp. So it is going to be A. Number 7, if a scatter plot constructed showing the relationship between the distance a student travels to school and the student's grade point average, what would the scatter plot look like? So we need to think about this. As the distance they travel, as that increases, does that affect the student's grade point average? I have no idea, because when I was a kid, I rode the bus, and I did my homework on the bus. So really, riding the bus kind of helped me with my grade point average. So, but some people, I don't know, if you're really far away, that might not be the exact same thing. So I'm going to go with B. I don't actually know what's going to happen, so it is B. Number 8, which scatter plot would be the best representation for the relationship, the number of hours a student studies, and the math scores? Well, in general, if the number of hours they study increases, the scores in the final exam should go up. So as 1 increases, they should increase, which is not F. Certainly not G. It looks possibly H, and J is just fine. So it is H. The more you study, the better your grades are going to be. And then our next one says, as the independent variable increases, independence the x increases, then the dependent variable decrease. That's the y decreases. So as we go from left to right, our graph is going down, which is going to be G. Number 10. Graph shows the change in price per gallon of gasoline over the past 6 months. If the pattern continues, about how much would you expect to fill up your car's 10-gallon tank during the 7th month? So first thing I think we need to do is actually extend this graph out. So there's 6, there's 7. So our graph would continue doing something like this, right? If there's 7, looking at that trend. So this is the price per gallon. So at 7, looks like it is, if we did this right, $2.75 maybe. So that's $2.75 a gallon for 10 gallons. That's $27.50. So C it is. And here in a little bit we're going to have something where we actually know for a fact using that data, not just guessing. We'll know for a fact. Alright, so now we hit linear regression. The rubber meets the road here. So first, correlation coefficient. This is a word we're going to use. It's the letter R. We will always see it as R. Is a measurement of the strength of a relationship, how strong it is, of a relationship between two variables. The strength of a relationship between two variables. If R is close to -1, it's always between, so R is always between -1 and 1. It's somewhere in there. But if it's close to -1, it's a negative correlation. If R is close to +1, I'm going to go and write that +1, it's a positive correlation. Otherwise, the data represents no correlation. Okay, now we are going to really use this here. So number 11. The table shows the number of woodpecker clusters in a forest. Use technology to write an equation that models the number of active clusters as a function of the number of years since 1990. So since 1990, that means we're going to change these numbers here actually to 2, to 3, to 4, because that's years since 1990. 4, 5, 6, 7, 8, 9, and 10. And then we've got, so these are going to be our x values, and these are going to be our y values. Now what we are going to do, I'll go ahead and pull this up. Alright, so you're going to go to your scratch pad. Alright, now we've got our numbers here. We're going to go to menu, statistics, stat calculations, and then linear regression. Now if you notice, it says X list and Y list. Okay, our X's are going to be the years, the 2, 3, 4, 5, 6, all the way to 10. Now, one important thing here is make sure that you put control in this parenthesis right there. You get these braces, these curly braces right there. You have to type in, it's a list of things. So we'll type these in, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, 10. And just make sure my data is all there. Yes. Pause this, please, if you feel like I'm going too fast. Okay, so make sure you put all that in those braces. Now, in the Y list, we're going to put braces, but we are going to put 22, comma, and the order matters, 22, 24, 27, 27 again, notice that, 34, 40, 42, 45, and 51, commas in between those. Okay, once you've done that, hit enter a couple of times, and you get something called a regression equation. So what this is, we're going to write this. It's mx plus b. So we're going to write, there's our m, there's our b, and there's the correlation coefficient right there. All right, so the data I've got, I don't think I can have these up at the same time, but I'm going to have 3.7x, so y equals, round to the nearest hundredth actually. Well, 3.7. 3.7x, and our b is 12.467 plus 12.46, actually we'll round it to 0.47. Now the correlation coefficient is the R value, 0.984. We'll go with that, 0.984. That's really close to 1, so that's that is a positive correlation. It's a positive correlation because it's really close to 1. Again, go back and watch that if you need to. Now, how many active woodpecker clusters would we expect in 2005? That we are going to plug in the year. How many years since 1990? That's 15. We're going to plug that in. 3.7 times 15 plus 12.47. And we're going to have to round it to the nearest whole number. So 3.7 times 15 plus 12.47 is 67.97. So we're going to go with 68 clusters. All right. Our next problem, next two actually, are just us finding the regression equation and the correlation coefficient. We don't have to predict anything. So we are going to take our x's and our y's. I'm going to switch back over to my calculator. All right, so I'm going to do menu, statistics, stat calculations, linear regression, mx plus b, that first one. And in my braces, I'm going to put 1, 1.5, 2, 2, 3, 3.5, and 4. 1, 1.5, 2, 2, 3, 3.5, 4. Okay. In my y list, I'm going to type in 3, 1, 1, negative 0.5, negative 1, negative 0.5, and negative 2. Hitting enter twice, I get this equation, negative 1.34, negative 1.34x, okay, and b plus 3.40. And my correlation coefficient there is negative 0.891. Negative 0.891. Still a positive, still a negative correlation. It's close to negative 1 here. Okay, next we have gas marks data. So going back to my calculator, menu, statistics, stat calculations, linear regression. And I have 2, 3, 4, 5, 6, 7, and 8. In my y list, I have 150, 160, 180, 190. Let's see, there's 190. I have 200, 220, 230. Enter. Enter. 13.57x. 13 how much did I just say? 57x plus 122.14. And my correlation coefficient is 0.995. 0.99 actually rounds to 6. 0.996. Really good positive correlation. Last problem. Find the regression equation and correlation coefficient for the data, and then we'll determine something else here. So we are going to, actually, this all we have to do is use this data right here. I'm going to go back to my calculator, menu, statistics, stat calculations, linear regression. Let's see, 59, 92, 56, 61, 59, 30, 65. 15.25, 23.43, 23.43, 14.13, 14.88, 15.11, 7.02, and 17. And our equation is 0.27, 0.27x and that is minus 0.72. And our R is 0.997. Okay, now the last thing is use the equation to determine how many kilocalories you could expect from a food that contains 33 grams of carbohydrates. In this case, carbohydrates, this is actually a y value, so we're going to plug that in for y. So 33 equals 0.27x minus 0.72. We will solve this, so we're going to add 0.72 to both sides. So we get 33.72 equals 0.27x dividing by 0.27. .72 divided by 0.27 gives us 124.89. So x equals 124.89 kilocalories. All right, that brings us to the end of these notes. And for my random math fact of the day, there actually is, and you'll learn this in Algebra 2, there is a number actually called I that you can actually take the square root of negative numbers. Shh, don't tell anybody I told you that yet. Okay, tune in next time for relations and functions.